In this problem, we're given that Fran's family has moved around a lot. Her street address has the following numbers: 107, 213, 219, 512, and 2118. Now it says let S be the set of distinct prime divisors of at least one of these house numbers. So let's stop right there and let's figure out what is S. When it says it's a set, that just means it's a list of possible numbers. Okay, so let's start with the first one, 107. Is 107 a prime number? Well, let's try dividing it by some other numbers just to be sure. We know it's not even, so we can't divide by 2 or 4 or any other even number. But let's try some other prime numbers. Let's try dividing by 3. That didn't work. We know we can't divide by 5 because it doesn't end in a 0 or 5. So we'll leave that. We'll divide by 7. Nope. The next prime number is 11. Nope. And one thing you can tell that you're done is that if the result you get is smaller than what you divided by, you don't have to keep trying other numbers. Because if you would get a prime number, you would have already used it already. So 107 is a prime number. So we're done with that. So 107 is a number in this list. So let's try 213. Not an even number, so we'll try dividing by 3. There we go. So we know that 3 works. Now what about 71? Is 71 a prime number? Let's try dividing it by 3. Nope. We can't divide by 5. Let's try 7. Nope. Let's try dividing by 11. Nope. And again, the answer we get is smaller than what we divided by. So we can stop. So 71 is a prime number. So far these numbers are in our list. 107 because we can divide 107 by that. 3 because we can divide 213 by that. Same with 71. So let's try 219. Can we divide this by 3? Yep, we can. And we knew that because, well, this is 6 bigger than 213. So it's just 2 extra 3's in there. Now I don't need to write 3 again because it's already there. But let's look at 73. Let's try dividing that down. Let's see if that's a prime number. So 3 didn't work, 7 didn't work, and 11 didn't work. So 73 is in our list. All right, so let's jump up to 512. So if we divide by 2, yep, that works. Now 256, that's an even number, so we can divide by 2 again. And so I'm not going to add 2 because it's already there on the list. But let's keep dividing by 2 and see how far we can go. So we just keep dividing by 2, and as it turns out, that's all that this was. It was just 2 multiplied by itself 9 times. That is the only prime factor there. So let's look at 2118. We know we can divide by 2, but we're not going to add it to our list. 1059. All right. So let's divide by 3, see if that works. Yes, it does. But we're not going to add that to our list because 3, again, is already there. Let's try dividing this by 3. Nope, that didn't work. So 353 divided by 7. Nope. So let's try dividing it by 11. Nope. Now again, the result is still bigger than what we divided. So we got to keep going. So let's divide by the next prime number, which is 13. Nope. The next prime number is 17. Nope. 19. But now we can stop because our result is smaller. So 353 is a prime number. All right. So this is our set, our list of numbers. So S is this set of distinct prime divisors of at least one of these numbers. All right. So now that we've got S, now we can move on. X squared minus bx plus c. All right. C equals 0. Now b is a number in S. Okay, so b has to be one of these numbers. And it also says that c, whatever it is a product of these 2 of these numbers. Now that's kind of the key to this problem. Because what that means is that we can factor this quadratic into 2 terms And what we're going to get is, if C is a product, then that means when we factor it, two numbers here have to be from this list also. Okay? Now, one other key thing is that B is negative. And so because B is negative, one of these terms has to be a positive, and one of these terms has to be a negative. So this one's positive, this one's negative. All right. Now, the key thing is that two of these numbers have to multiply and give us C. Whatever C is, we don't know. Two numbers from this set also have to add up to this. So, the key to this problem is realizing we don't know anything about C. That's what we're trying to find. But we do know that whatever B is has to come from this list. But we also know that these two numbers have to come from that list. So really the key question here is, how do I take, we have to take two numbers and add or subtract them and get a number from this very same list. That's what we have to do. So, what two numbers could we add or subtract? Well, these two, 71 and 73. Because again, one of these has to be positive and one of these has to be negative. So if this number is positive 71 and this number is 73, what would happen if we expanded this out? We would get x squared minus 73x plus 71x minus, and then we'd have to multiply 71 times negative 73. And we get negative 5183. And so we get x squared minus 2x minus 5183. And so the conditions are met because this number is in our list. And this number we got by taking, now this is key, they said absolute value of C, so we can disregard the negative. So 5183 we got by taking these two numbers, 71 times 73. So the problem asked, what is the value of C? Not absolute value, but C itself, which is this number, negative 5183. That is the value of C. There's our answer, and we're done.